All right, so number 19. This time we're selecting three things with replacement. With replacement makes things easier. We don't actually have to do that counting business and figure out what we've removed and what we haven't. Probabilities should remain the same. So in this particular question, we're dealing with 8 kittens. So I'm going to draw my kittens out. 3 of which are black kittens. My kittens are not very attractive. I should have drawn them before I started making the video, but it's too late now. So we've got our 3 black kittens here at the end. They are a little deformed, but we can manage with them. The other kittens are other colors, but we don't care. They're just not black. So first question we're being asked is, what is the probability that all 3 kittens are black? So we need 3 kittens, and that's going to be true for every problem here. In this case, what needs to happen for all 3, every single kitten is black, right? So probability the first kitten is black, well, there are 3 black kittens out of a total of 8 kittens, right? So 3 over 8. Since all we did was look at this kitten, decide that it was black, and put it back into the sack of kittens, our probability on the second kitten of it being black is still just 3 over 8, because we're putting it back in. After we take this kitten out, we look at it, we put it back, and the third probability is still 3 over 8. So that is how your probabilities will work for the with replacement. Much easier. Every time you have anything that's a black kitten, it's just going to be 3 over 8. Now, for the probability that exactly 1 will be black, most of the mistakes here come from the fact that people forget we still have to get those 3 kittens at the end of the day. So you still need those 3 different trials, 3 random things that have to happen. In this case, we want only 1 kitten to be black, right? So we got a black kitten. The next 2 are just not black. So we'll use the complement notation to mean not black kittens. Here we have to pay attention to the same thing we did in number 17, that this black kitten, it was arbitrary that we chose to put the black kitten first. We could also have gotten the black kitten second or third, meaning that there are 3 ways in which this could have happened. So we need to do our times 3 as our shortcut instead of doing 3 different calculations. And then we throw in our probabilities. First one being black, well, black is always 3 over 8. Not being black, well, that's the remaining 5 kittens out of the 8, so that's 5 out of 8. And not black again is still 5 out of 8. So multiply all that together and you'll have your answer. Now, the last question is the trickiest here. It asks for what is the probability that at least 1 kitten selected is black. At least 1 means it could be 1, could be 2, could be all 3 kittens being black. Now, we've already found 1 and 3. It would not be that hard to figure out what 2 was and add those 3 probabilities together. Essentially make that discrete probability distribution we learned about last class, right? We know 1 already, we know 3. All you need to figure out is 2, and you could add those up. But that's more work than we need to do. We're going to use the idea of complements instead to answer this for us. So we happen to know that the probability of at least 1 is the opposite of the probability of none. Those 2 things are complements. If I hadn't erased my little drawing over here, right, with the 0, 1, 2, 3, I circled these. 0 was the only thing left out, right? So if we just figure out none, we can do a 1 minus. I'm not going to do that for you. I'm going to make you guys do that on your own. But I'm going to tell you that there are still 3 kittens in order to get this none. And if none of them are black, every single one is black complement, right? So whatever you calculate here, don't forget to plug it back in and do a 1 minus in the end.